If you're interested in building projects and working with electronics, you're already familiar with the capabilities of the ESP8266 and Arduino. These platforms provide great power for different project ideas. But have you ever thought of taking things to the next level? Combining these tools with Blender can unlock a world of possibilities. In this video, I'll show you how to interface with Blender and take control of 3D objects using the trusty ESP8266 and Arduino. In the first part of the video, I used Arduino with Blender, and in the next part, I will use the ESP8266 with Blender. In this video, I'll be using the Blendix Serial add-on for Blender and the Blendix Serial library for Arduino. If you're not familiar with these tools, you can check out my previous video where I explain them in more detail. Now, let's dive right in and get started. In this first demonstration, we'll start by understanding the concept. We'll begin by reading data from the HC-SR04 sensor using Arduino. Then, we'll send this data to Blender, where we'll visualize it using Blender's 3D objects. This will be achieved using the Blendix Serial add-on and library. Let's go through the Arduino code that will be used to send data to Blender. The Blendix Serial library is used to communicate with Blender and control 3D objects. The new ping library is used to work with the HC-SR04 sensor, which measures distance. Defines the pin configurations for the ultrasonic sensor, trigger pin and echo pin, as well as the maximum distance to measure. Here, an instance of the new ping class is created with the sonar object and instance of the Blendix Serial class is created with the Blendix Serial object. In the setup function, serial communication is initialized with a baud rate of 9600. In the loop function, a delay of 50 milliseconds is used to ensure a smooth and stable loop execution. The ping function is used to measure the distance in centimeters using the SR04 sensor. The result is stored in the variable value. Here, the coordinates are being set for object 1 using the setCoordinates function with the values of the value variable, which is the distance measured by the ultrasonic sensor. The values are sent 3 times for x, y, and z coordinates, respectively. If you choose to send values for only one coordinate, set the remaining coordinates to 0. The getFormatedOutput function is used to obtain a formatted string combining the coordinate data. This string is stored in the variable output. The output string is then sent to the serial using serial print. Connect your Arduino board, compile the code, and upload it. Here's I have created a simple ultrasonic sensor 3D model. If you haven't had any experience with Blender yet, don't worry. There are plenty of resources available online, including 3D asset stores where you can find pre-made 3D models. You can easily download these models and use them in Blender to enhance your project without the need for complex modeling. However, if you'd prefer to explore your creativity, feel free to create something different that suits your interests. To animate the sensor data in Blender, I'm using a cone mesh object with a wireframe modifier. For actions and operators, I have enabled the screencast keys, so you can easily follow the steps along with me. You can also watch the operators box to see the values I am using. Our object animation is complete. When I scale the cone on the z-axis, it creates a cool beam effect. It's not perfect, but it can do the job. By applying the sensor values to the scale property along the z-axis, our data is displayed as laser beam effects. To enhance the visualization, we can add an object in front of the cone to give the appearance of the sensor measuring the object distance through the laser beams. Let's add a cube in front of the sensor. To animate this cube based on the sensor values, there are two ways to achieve this. The first method involves sending the sensor values from Arduino to Blender using the set coordinates function for the second object. Then, we can apply these values to the cube, and the cube will change its position according to the sensor data. The second method is to apply object constraint properties to the cube. This approach is more versatile because it allows us to save the set coordinate function for another sensor. Let's use the object constraint method and apply the cone object properties to the cube. Select the cone as the target object and map the values from scale to location. Since we are applying the sensor values to the cone scale properties and want to change the cube's position according to the sensor values, we'll map these values from the cone scale to the cube's location along the axis. Feel free to change or adjust the values based on your objects. Let's add a text object to display the sensor values in the 3D viewport. Align the text object as you prefer, and you can also modify the text properties to your liking. Make sure your hardware setup is ready, and after that, provide the connection settings and connect the board. In the Object tab, you can select the cone object from the drop-down menu along with its properties and axis. When you click the Start Movement button, the cone object will change its position based on the data received from the sensor. As you can see, the mesh animation looks great and gives us a nice laser effect. However, it all depends on your creativity in making different visualizations using the objects. In Blender, the data visualization depends on your Blender skill level. As I'm not a professional 3D artist, the Blender serial add-in I created only manipulates the objects by adjusting their transform properties. It doesn't involve frame animation. The Blender serial add-in uses a timer-based technique to animate objects within the scene. This technique involves registering a timer that calls a specific function repeatedly at regular intervals. You can find all the details in the information page. I have created another project. In this one, I used the famous LM35 temperature sensor with Blender. The temperature sensor values are used to rotate the gauge needle according to the temperature. Additionally, these values are utilized for the text object in the digital thermometer, which also displays the temperature values in Fahrenheit and Kelvin formats. Using the hot air gun, I have increased the temperature, and you can see that the needle and text values are updated accordingly. In our next video, I'll be sharing some projects using Blender Serial, ESP8266 and Arduino. Make sure to stay with us to see these exciting demonstrations.